All right, so the important part about this and like how you approach these is important because you are ultimately trying to find one of these to prove that these two triangles are congruent. And then you're given two things. This picture gives you both things. So the first thing that's given is JK and LM. So JK and LM. Everybody see that? It's given right here. It's also given in the picture. And then if you look in the picture, there is something else that's marked. Great. We can write that down. So these are the other markings. So you just have to be able to identify. So JM is one of the markings. Where am I getting that? J to M is marked with two of these tick marks. Okay? And then you look over here. KL is marked with two of those tick marks. Great. So we have everything that's given now. And then there's one other thing. One thing I want you to notice that there's no angles marked, but there is a shared side. Okay? And then our warm-up, we talked about this right here. It's called a reflexive side. It's a side that touches. So we can actually mark that one congruent. So there's a couple things that you always look for when you first look at triangles. And if you have two sides that match and they touch, you can automatically mark those congruent because they are touching. So from J to L on this top triangle, it's congruent to JL on the bottom triangle. Y'all see that? Top triangle has a side called JL. The bottom triangle has a side called JL. And so you can mark them congruent. And then you use the little congruent symbol to do that. And then Y is the case. So that is a new word for you guys. And that is the reflexive property. I kind of think of it as like a reflection. Like you look in a mirror and you see your reflection. And reflexive kind of sounds like that. And so that helps me remember. But that's the reflexive property. And on your assignment today, you are given a list of these. Like you don't have to just have them in your brain. You're given like a word bank, okay? So don't worry about that. And then now we have proven these things. So I want you to look at your picture. Look, all the sides are marked. So one of the sides is here, another side is here, and a third side is here. And then look, that's one of your reasons, right? All three sides being marked congruent is one of the reasons. And so the reason you know these triangles are congruent is because of side, side, side. Okay, so we're going to move on to the next one, and there's two things that are given here. The first thing is given is that angle BDC is congruent to angle ABD. So write that out, and that literally comes straight from there. I copied it down. I'm not thinking of anything to figure that out. But now we've got to find those and actually mark them on our picture. Things won't always be marked on your picture to start with. Sometimes they're written, and you have to mark them yourself. So let's do that. So let's find BDC, and let's mark it. And then let's find, and then make sure you see like how I'm finding this. A, B, D, and let's mark it. Great. So those are congruent. And then something else is given. AD is parallel to BC. Wonderful. So AD is parallel to BC, and that is actually already marked for us. These do not show congruence. Arrows don't show congruence. So just make sure you see that. Like the arrows, these are arrows. Arrows don't show congruence. They just show that they are parallel. All right, so this means parallel. All right, where does that come in? Okay, this is honestly, this is the hardest part of the entire unit. Like if you can grasp this concept, this is the most difficult thing, I think, in my opinion. These two lines show that they are parallel, and then there's a line running through here. And then I want you to remember back to the previous unit where we had alternate interior angles. Does that ring a bell at all? Like a transversal running through two parallel lines. You've got that on these triangles here. You've got two parallel lines, and then BD is your transversal. Okay? So in order to have alternate interior angles, you have to have your parallel lines, and then in between them, you will have, on the interior, these angles. And then what's important is these angles are going to touch the parallel line. So see how that angle touches that parallel line? This angle touches this parallel line. And then they're on alternate sides of this transversal that runs through here. So if you want to like extend that line out a little bit to make it make a little more sense, that's going to be angle ADB, which is congruent to angle CBD. Okay. Okay, and then now I want you to label what we have going on here. So either A or S. So that is an angle that is congruent. Here's another angle that's congruent. This is nothing. This is not an angle nor a side. It shows that it's parallel, but we're only writing letters next to ones that show like congruence, okay? And when we have one more blank, so the last thing I want to show you guys here is like these sides right here touch. These are reflexive sides. So just like before, you see how they touch? Reflexive sides. Wonderful. These are congruent sides. So BD is congruent to BD. How do we know that? Because of the reflexive property. Okay, and then here's the last tricky thing, is you've got two angles and one side, but you have two choices here that it could possibly be. And if you just look at this proof, you're like, oh, it's angle, angle, side, and we're done. But that would be wrong. Okay, so look at that picture, and then I want you to notice and cover up one side right here. So take your hand and like physically cover it up. So you've got an angle, you've got a side in between that angle, and then you've got another angle. If you do not cover this up with your hands, it's a lot harder to see. You've got an angle, a side in between, and another angle. You do not have angle, then side. There's like a side sandwich going on here. And you have angle, side, angle. So we switch to the top of the next page. Go ahead and write these givens in. Okay, so what the heck does midpoint mean? So we've talked about the word midpoint before, and it means the same thing as bisects. So do you guys remember what bisects mean? It's like 3 words, and I'm going to say bisects, and I want you all to say what it means. Bisects. Oh, okay, yeah, cuts in half. So, yeah, the midpoint cuts the 2 lines in half. So here we go. We've got C is the midpoint, or it cuts in half AD. So find AD on your picture and realize that C cuts that in half. So, like, AC should be the same as CD. How do you know that? Because the midpoint cuts that in half. And then you can do the same thing for the next one. Okay, go back and fix this. I obviously can't copy very well. Now we're just going to go and we're going to write the things that we marked. So like C is the midpoint of AD. So we knew that C cut AD in half, so we can mark the 2 sides the same. So this is not like overly complicated, okay? But it does require you to understand what's happening. Midpoint means cut in half. So since we've cut those in half, we have to mark these 2 halves congruent. So AC is congruent to CD. So I've done that for one of them. Now I want you on your paper to do that for the other one. Oh, and the reason that you know, I don't know if you guys remember, but remember last time we did proofs, anytime you would see this word, we would highlight it and we would put that definition of midpoint. Ugh, I cannot write today. We would write that here. So this next one is actually going to be the same reason, definition of midpoint. And I want on your paper to put, which ones are congruent. Okay, so hopefully you have that BC is congruent to CE. And like, honestly, everyone's paper that actually had stuff written on, you had the correct answer. Okay, so that's good. We're going to go to the next one. And what I want you to do is first just look at the picture, okay? Look at your picture and make sure the important part about this is making sure that you listen to what I'm saying, because if you're just not listening and then writing this down, you're not going to know what the heck is going on. This is not, like, just make sure you're paying attention. So BC is congruent to CE. Oh, I should have little congruent symbols. And then the last one, look at the picture. You have, it looks like a bow tie, right? Anytime you have a picture that looks like a bow tie, just like on our warm-up, we wrote this in. you're going to have vertical angles, okay? So you're looking like, oh, there's a bow tie there. Great. I've got vertical angles. And you can even write in the reason vertical angles. You don't necessarily have to go from one side to the other. You know there's going to be some vertical angles here because of what's written. So we have a side, and we also have vertical angles. It obviously can't be in that order, but those are the three things that we have. So vertical angles, angle BCA. If you guys struggle with naming angles, this will be some good practice. BCA is one of the angles, and the other side is DCE. Okay? And then you've got to look at your picture. You got to cover one up with your hand, and you got to say, okay, I've got two sides and one angle. The angle is sandwiched in between the two sides, so it has to be side, angle, side. Okay? Okay, so I went ahead and wrote in the givens. This talks about AB and DC being perpendicular. And so if two things are perpendicular, you can go ahead and mark these as right angles, because two things that are perpendicular, two lines that are perpendicular form right angles. So angle ABC and angle ABD, so that this one and this one are right angles, which, awesome. Those are right angles. Therefore, DAB and CAB are right angles is the definition of right angles. Okay. So the fact that these are right angles allows you to show that they're right angles in that. So we now have this right angle, and we have this hypotenuse, and then we have this reflexive side. So this is like the third time today we've talked about this reflexive property. So AB is congruent to AB. How do we know that this is congruent? It's going to be HL, because we have L, and this is actually, it says a side, but it is the hypotenuse. So we've got two sides, and we have an angle. One of them is the hypotenuse here. All right, we're actually going to go back to this page. I'm going to pause the video, and I'm going to write the givens. All right, so here are the givens. So I'm going to go ahead and mark them. Angle S is congruent to angle U. So that is an angle. And then TR cuts this angle in half. So this is the first one where we've had a segment cut an angle in half. So we know that if TR bisects or cuts this angle in half, that means these two halves, the top angle and the bottom angle, are going to be congruent. And so that's how we know that SRT and URT are congruent. So SRT is congruent to our URT because of the definition of bisects. This is another one of these words that we learned back for our previous unit, where if you see that word, the definition of that word will be later on in the proof. Okay, so definition of bisects, and that is another angle. And then our third one is you've got another shared side. So this is like, this continues to happen, either vertical angle or shared side. It's going to happen in a lot of proofs, but RT is congruent to RT, and that's the reflexive property. And then you honestly have two choices here. You've got two angles and one side. So if we look at our foldable, two angles, one side, all right? It's either going to be angle, side, angle, or angle, angle, side. Here's my two angles. Let's cover this up. Is my side directly in between my two angles? And the answer is no, because the angles here. It would have to be this side that's marked congruent, and it's not. So it is angle, then the side comes around, okay? Angle, angle, side. And it just happened to be written in that order. That will not always be the case. But those are all the notes for today. Thanks.